Area of regular polygons. Some vocab to get started. The center of a regular polygon is defined as the center of a circumscribed circle. Circumscribe means along the outside. So if I was to circumscribe a circle, that would mean it would touch at only exactly one of the vertices of this polygon. The center would be directly in the middle. The radius in a regular polygon is defined as the distance from the center to a vertex. So to draw a radius, we would start at the center and go to one of the vertices. Apothem is defined as the perpendicular distance from the center to a side. So the apothem would be the perpendicular distance here. Typically this is called R radius, A apothem. Center right in the middle. The central angle is an angle formed by two radii drawn to consecutive vertices. By two radii drawn to consecutive vertices. So for example, I'm going to erase all this and we're going to draw in red a central angle, starting at the center, two consecutive vertices. This is the central angle. Now, let's think about this central angle. Can we find out the measure of the central angle? This is a 1, 2, 3, 4, 5, 6-sided figure. It's a hexagon. All around in this, the entire degrees in this area is 360. So the central angle would be 360 divided by 6, or 60 degrees. For this particular setup, the central angle is 360 divided by the number of sides. Now, let's try to figure out if we can find the exact area of a regular nonagon, 9 sides with apothem 9. Okay, so first of all, the first step really is to find the central angle. You'll see at the bottom of your notes. Your notes are a little bit different than my notes. So you already have central angle written here, and I'll have to write it in. Let's find the central angle for this problem. Well, it's 9 sides. So the central angle would be 360 divided by 9, which is 40. The central angle is 40 degrees. The apothem, which is the perpendicular distance from the center to the side opposite, is 9. Now, we know that this is an isosceles triangle. If the measure of this whole angle is 40, half of this angle must be 20. So I believe you have a sketch of this. I'm going to take one of these triangles here. You already have this drawing, and I'm going to lay it out. By the way, how many triangles are they in this situation? There are 9 of them. Okay. We know the apothem is 9, which is the same as the number of sides. And each of this is 20 degrees. 20 degrees. So what's this one down here? Well, this one is 70 degrees. Maybe it's important to use, but I don't think we really need it. So to find the length, if we wanted to find the area of this triangle, we'd have to find the base. Well, the base is half. The base would be double if we could find this distance from here to here. x, which goes from here to here. We can use the tangent function to do that. The central angle is 40 degrees. And now we want to find the area of one triangle. You have a nice clean sheet of this. You don't have to be looking at my messy handwriting here. So to find the area of one triangle, we would have to find x first. So to find x, we do the tan of 20 equals the ratio of the opposite side over the adjacent side. If you do that math out, you're going to get about 3.28. You should verify this. And that means the whole length of this triangle here, this isosceles triangle, the whole length of the base is 6.55. This whole thing is 6.55 or 6.56 approximately. So to find the area of one triangle, we do 1/2 base times height. 1/2 6.55 times 9, which is approximately 29.48. To find the area of the entire nonagon, we'd have to multiply our answer for one triangle, multiply that times 9, and that answer is approximately 265.275. Turning the page. Again, my notes are slightly different than yours, but basically it has the same thing. In general, to find the area of a regular non-n-gon, you already have this on your page. To find the area of a regular n-gon, number one, you break it into triangles, and you draw one and focus on it. Find the central angle is the second step. Draw and determine the lengths of the side, apothem, and radii using trigonometry or special right triangles. And then find the triangle's area and multiply to find the polygon area. Now my notes are a little bit different from yours because under here it tells you some special areas of polygon. It has polygon areas. And those are n times 1/2 SA. Well, you have them in your notes, so why don't you look at them, and if you have any questions tomorrow in class, you can we can discuss it. My example 2 and your example 2 are different, so I'm going to not you do this one. My example 3 and your example 3 are the exact same, so let's do this together. Find the exact area of a regular hexagon, which has 6 sides, with a radius of 8. So again, step 1 is to find the, exact area. So that might be, we have to do square root. We have to find the central angle of a hexagon. That would be 360 divided by 6, which is 60. But again, half of that is going to be 30. So each piece of these is going to be 30. That means this has to be 60. Now this is a 30, 60, 90 triangle. Radius of 8. So again, the side opposite the 30 degrees is the smaller side. So that means this side would be 4. And the whole length would be 8. The altitude is opposite the 60 degrees, so that's 4 root 3. So to find, so the 2 bits of information that we had to do is we had to find the apothem, and we have to find the length of the side to do our area of a regular hexagon. The area of the entire hexagon is equal to 6 times the area of one triangle. The area of one triangle is 1/2. I have 2 cats and they're both circling me right now. I have 3 cats, but 2 are here. 6 times 1/2, and that's 4, which is oh, I'm sorry, not 4. The whole base is actually 8. See, I have to be serious about the math here. 6 times 1/2, 6 triangles, 1/2 base times height. The base is 8, and the height is 4√3, which is the apothem. So we have to simplify this. Well, 2 goes into 8 4 times. You have 24 times 4. The final answer is 96√3, and that's the exact area. Your example 2 asks you to find the area of a nonagon with radius equal to 10. So I'd like you to try this at home right now using the directions that we did, or that I gave you for the 1. And then the very last one, your example 4, is the same, where it wants approximate area. So for approximate, you're going to be using trigonometry for example 4 and example 2. So you're going to do example 2 at home and example 4 at home. And we will talk about these in class and any clarifications next class.